Hey, welcome back, students. In this video I want to go ahead and show you how to make a conversion of temperature from Fahrenheit to Kelvin. And so I've already set up the blank template here at the bottom, and let's pretend that we're going to go ahead and convert 21 degrees Fahrenheit, and we want to convert that to Kelvin. Notice that the units here, if we want to do this, we're not going to be able to do this directly, so we can't go from Fahrenheit to Kelvin directly. We first need to take a side road trip over here and solve for degrees Celsius before we can make it to Kelvin. So that does require us to use the other equation that we used in the previous video when we're converting from Celsius to Fahrenheit, or from Fahrenheit to Celsius, and we need to use that here first. So we first need to take the equation, which is this one here, degrees Celsius equals degrees Fahrenheit minus 32 times the 5 divided by 9. And we're going to use this as a starting point. We are going to take this 21 and we are going to replace the degrees Fahrenheit symbol and then solve for degrees Celsius. Once we're done with that, we'll take the next step and convert to Kelvin. So when we do this, we're going to take this 21 and we're going to replace it right there. And so that gives us the following equation. Degree C equals 21 minus 32 times 5 divided by 9. Okay, if I go ahead and solve for 5 divided by 9 here, that's going to give me the following number. 0.555 repeating, and this is going to be multiplied times the 32, and I'm going to go ahead and bring down the rest of the equation so the minus sign comes back as well as the 21, and this will be equal to the degrees Celsius. Now the next step is to resolve this portion of the equation, and I'm going to take 0.555 and multiply that times 32, and when I do that, I'll get here, for this particular section of the problem, it's going to be 17.77 repeating, so I need to bring down the minus sign here and the 21. That should give me degree C here. And so all I really need to do now is to go ahead and take 21 and subtract the 17.77. That should result in the following answer for degrees Celsius. 3.23 degrees Celsius. Now remember from one of the previous videos where I showed you how to convert from Celsius to Kelvin, we need to take that step here. So if you're not familiar with how to do that, go back and watch that video first before you proceed. But essentially here the step is we need to add 273 to this, and that should give us the final answer. So we're going to add 273 here, and that should give us the units that we want in Kelvin, and that should be 276.23 Kelvin. Now I know that many of us want to stop here, but keep in mind, what is the original significant figures? Now in the previous example I showed you how to round something to 3 numbers, or 3 significant figures. This problem is a little bit different in the fact that I've only given you 2. So kind of throwing you a little bit of a curveball. You need to know how to convert this, and you need to recall how to convert numbers back into scientific notation, which is one of the requirements here. I did record a video in the past and put it on our website. Go ahead and back and check that video out if you need a little bit of help there, but I'll walk you through the process here. So since we only have 2 significant figures up here at the very top with the 21, the 2 numbers that I'm looking at specifically is the 2 and the 7 in the whole number. Since these are the numbers, I need to take into account the 6, and I need to ask myself, is the 6 equal to 5 or greater than 5? Obviously the answer is that it is greater than 5, so we're going to look at this being a +1 situation when it comes to the 7. So I'm going to have to increase that 7 value to an 8, and so that does the following. That gives me a 28. Now keep in mind that scientific notation requires me to put the decimal in after the first significant figure, and then I'm going to multiply that times 10 to some number or some exponent. And that exponent is essentially the space between where the decimal exists and where I really want the decimal to be. Since the decimal does exist already naturally after the 6, but I want it after the 2, the space between these 2 decimals is going to be 2. So my exponent in this case is going to wind up being a 2. So my final answer here in terms of Kelvin temperature is going to be 2.8 times 10 to the 2. So whenever you're looking at solving any problem, please be careful, look at the significant figures and report your answer to that number of significant figures. Okay, any questions? Come and see me in class.